Hi guys, this is Vijay. So today we are going to discuss about that Arista MLAG. When I say the Arista switches, these are the in data center switches where just like in a Cisco devices, we have the VPC concept where you can bundle the two physical devices into the logically single virtual switch and configure the high availability. Similarly, we have a MLAG concept we call the multi-chassis link aggregator for the Arista switches. So we are going to take a look of what we are going to get from this concept in Arista and how we can achieve this scenario in the lab. So the traditional way of looking the network here is if without MLAG or VPC or any non redundance technology, if you're going ahead with the straightforward with the spanning tree, the major challenges of the spanning tree is a blocking port. If you're having the high availability of interface between the switches, between the access and distribution, wherever you have more than one interfaces between the switches, one of the interfaces will be in a blocking state, and one of the interface will be in a forwarding state. That was the challenges we had in a traditional networking where you cannot have more than two or one link as an uplink for the high availability of the any particular devices. So to overcome from these challenges, we have various technologies such as BPC and MLAG and the stacking, a lot of other things to bundle the switches. So in Arista, we have the MLAG concept where we can eliminate totally STP between the switches and configure those switches as an active manner. And this two particular feature, MLAG feature, this allow the two Arista's 7000 family switches to stack that and for the L2 purpose and eliminate that the STP from the network. Well, the key benefit of the MLAG is no waste of bandwidth for the uplink. So all the link will be as active, and there won't be any allow you to allow the network design for the non-blocking network. So you do not have any kind of reliable or active standby concept. You will better utilize your network. Then you have maintained the same level of resiliency with the path available for all the time. Two Arista 7000 series switches can be MLAG pair, increase your network resiliency 2x. The no property protocol, use it for the MLAG configuration. So this is the open standard protocols. There's MLAG is not the property protocol for the Arista or for any vendor. Up to 16 1 gig or 10 gig port can be aggregated together and spread across the two switches for the better high availability. Spanning tree protocol can be used conjunction with the MLAG to detect that, handling that misconfiguration, all these aspect of that. Now, if you see that here, so we have the four distribution switches, leaf 1, 2, 3, 4. So out of these four switches, I'm going to configure the MLAG on the leaf number 1, leaf number 2. I already have the MLAG over here. I have MLAG over here. I have MLAG over here. So this is basic to advanced MLAG configuration. Basic means you are pairing that one pair of the switches as a MLAG. Whereas if you're having the back-to-back MLAG for entire, even spine switches also acting as a MLAG box. All the leaf switches are acting as a MLAG box, and you are configuring these things as a port channel MLAG. It means this we call the back-to-back MLAG configuration. This is the advanced configuration. So we have this kind of scenario where I'm going to configure leaves layer as a access or distribution layer switch, where I'm going to have a directly host connecting to my devices. On the spine layer, I'm going to have the gateway for any host which are sitting in the network. So this is the topology I have. Okay, this is the topology I have. So currently, this is the two spine switches. On the spine switches, I have VLAN 12, which is going to be SBI configuration, and I will configure the virtual address, unlike the all the other devices where you need VRRP, HSRP configuration. In the Arista devices, we have a concept called the virtual IP address. irrespective of the subnet, what subnet we have, we can generate the virtual IP address using the same VLAN concept, And we have a leaf 1 and 2. I'm going to configure this leaf 1 and 2 as a MLAG device, and I will configure. Here I'm going to get the MLAG device. I will stack this leaf 1 and 2, and I will configure these interfaces also as a MLAG port channel here. Then I will try to ping from this host to this particular leaf spine switches SBI address. So let me open the topology which I have here with me. Just give me a second. Okay. So this is the Arista lab which I have here. I have a leaf 1 and 2 and Arista switches 1 and 2 where I have. Now, if I go to the leaf 1, okay, leaf 1 switches, and if I log into the leaf 2 switch also, we will see that using the LLDP neighbor, interface 1 and 6 are connecting to each other. Interface number 4 is connecting to another switch, which is connecting like this for me, which is acting as a host device. And I have VLAN 12 host connecting to this particular box. And I have a trunk between here and here as a trunk interface. I'm configuring that. Okay, so if I open to the leaf 1 and 2, sorry, this is a spine open leaf 1. If I open the leaf 1, okay, so if I see that, so LLDP neighbor, so LLDP neighbor, oh, not neighbor, spelling is wrong, neighbor. If you see that interface number 1 and 6 connecting to the leaf 2 from the leaf 1, and the 2 and 3 connecting to the spine, and 4 interface connecting to my host interface, which is this exactly the same configuration. So if I show here, leaf number 1 and 6 connecting to here, leaf number here, leaf number 1 and 6 connecting to my if I maximize this page, just hang on with me. Okay, here we go. Leaf 1 is connecting to the leaf interface 1 and 6 connecting to the leaf 2, and the interface number 2 and 3 connecting to the spine switches. So if I go to my leaf 1 and say the show run configuration, in the show run configuration, I have created the VLAN 12 and 13, and yeah, that's it. I have not created any interface. I have not configured anything. Okay, so very first thing is what I will do here is I will config T. I will say VLAN 12 and VLAN 34, for example. I want to create it over here. Okay, now I will exit it. Then I will configure the port channel. Very first thing I will configure here is the port channel between the leaf 1 and 2 using the interface number 6. Okay, so if I go to the interface number 1 and 6, interface Ethernet 1 and Ethernet 6, okay, then I will say that description, I will say that MLAG peer link is leaf 2. Okay, then I will say that switch port mode trunk. Then I will say that enable the LACP channel group port channel number 10. If you say that mode LACP active mode, I'm going to have, then I will shut down this interface. No shutdown. Okay, then I will create the port channel interface port channel number 10. I will say that switch port description, I can keep that the same. I need to, if I copy from here, I will paste it here. Then I will say that switch port mode trunk. Then I will say that switch port trunk group, what VLAN I want to allow. So I have created the one VLAN group, which we call that VLAN 4096. In MLAG, especially to the Arista switches, you cannot configure the MLAG without using the one dedicated VLAN, which going to use for the communication between the switches. Okay, when I say that it's going to use for communication between the switches, it will be perform the status update and communication between the switches using this link. That's the reason we use VLAN 4096 as a kind of local IP address, which will be using for the control the traffic on the peer switches. Okay, I will create 4096 as a SVI interface. Then I will use this IP address as a interface as a MLAG source. And MLAG is just like a peer keep alive we have in a BPC. Similarly, here we have the 4096 VLAN. However, if you're using this particular VLAN for the peer communication between the switch 1 and switch 2, make sure that you disable the spanning tree on the switches to avoid any kind of loop or any kind of issue on the device. Now, what I'm going to do here is, since I already have created the peer group, MLAG peer, I will call this, I will have to copy it here, paste it, done. Once I will done this configuration, my interface should be working fine without any issue. On the port channel number 10, I will say no shut. Okay, then I will say that, just give a second. I will log into the switch number 2. Same thing I will do here is, okay, config team. I will say that VLAN 12 and 34, which I'm going to use for this configuration. Even if we can say the VLAN 4000 for the 94, which I'm going to use for peer link, I will say that the command I have to run here is a trunk group MLAG peer. Okay. Then I will say that no spanning tree VLAN ID 4094, because I'm going to use this link for the our MLAG configuration. Then I'm going to use interface Ethernet 1 and 6. I will say that the description I'm going to use here is MLAG peer link leaf 1. Okay. All right. Then I will switch port mode trunk. Then I will see the channel group 10 mode as a active. Then I will say no shut. Then I will say that interface port channel number 10 description. I can give that description MLAG peer link leaf 1. It's the same different description. Switch port mode trunk. Then I will say that I'm going to allow on this trunk port one VLAN, which is your MLAG peer. I will call this particular group under my trunk port. Once it is done, then I will see that shut down. Then I should have interface in running without any issue. So if I go exit, so ether channel ether channel so port channel, I should have this command to check that interface. equivalent to the so port channel. Okay, so it's saying that port channel 10 is created. If I go to the say the summary, I will say that 10 brief. So it's saying that port number 1 and 6 is connecting to this. If I go to the so interface status, if you see the port channel number 10 is connected and it is trunk port, and the interface number 1 and 6 is configured to the switch 1. Same thing if I go and check here, so interface status, exact same configuration you will find over here using the port channel number 10. Now our task is to configure the MLAG now. Okay, in order to configure the MLAG, make sure that the port channel and the VLAN group, all these things should be enabled. However, also SVI interface VLAN 4094 should be configured for the local health communication, okay, between the MLAG devices. I will see the description. Okay, in a description, I will say that, just give me a second. MLAG peer link. Okay, then I will say that IP address 172.16.12.1/30. Okay, no shutdown. Same thing, I will go and configure on the switch number 2. I will say that interface VLAN 4094, IP address 172.16.12.2/30. No shutdown. Description, we can give that like MLAG peer link. Okay, if I try to ping that 172.16.12.1, it should be reachable between the here using the port channel 10. Okay, now if you want to configure the MLAG device, MLAG configuration between them, what we have to do here is, if I go to the switch 1, I will configure first. I will say that MLAG configuration. Okay, then I will say that domain, just like a BPC domain, I will configure the MLAG string MLAG, for example, 12. Okay, then I will say that use my local interface VLAN 4094 for the peer communication. The peer ID, peer address is, what is the IP address of the VLAN? 172.16.12.2. Then I will say that peer link, the peer link which you will use for communication is a port channel 10. That's it. You have to configure this much only. Okay. Now, if I go to the switch 2, I will repeat the same configuration. If I go to the switch 2, I will say that the MLAG configuration, the domain must be, domain ID should be the exact same, otherwise it won't work. Local ID, local interface, VLAN 4094. Then I will use peer IP address 172.16.12.1. Then peer link port channel 10. This is the all you have to configure. You don't have to configure anything else to bring the MLAG interfaces. Okay. Now, if I want to check the MLAG details and all the verification you want to do here is, it's a simple, straightforward. You can check the MLAG configuration. What are the commands we have? Whether if MLAG is coming up or not. If I show the so run, what I have configured here is, this is the MLAG configuration I have done. Okay. If I go to the switch 1 should also have the same exact configuration. MLAG configuration I have done here. Now, if I check that, so MLAG. Look here, what is saying that this switch is part of the MLAG 10. And currently, this switch is currently acting as an active. Negotiation is active. There is no issue with it. Okay. Now, if you see the port details, can you see the full active is 1? Okay. Now, if I go to the switch number 2, if I see the MLAG, MLAG, you will see that this switch is also saying that active, because both the switches act as a active devices. If I say the IP interface brief, this is the IP address of local, this is the IP address of the peer. Okay. Now, if you want to check the more on the MLAG command, how this command should be reacting, how it should be, each and every command has a meaning. Definitely each and every command has a meaning in the devices. Okay. Now, second thing is you will check here is MLAG interface. Can be saying that only interface port channel number 4 has been configured for the MLAG device. Now, what I will do here is, if you see that this port 1/4 I have configured as a port channel, and I have associated this port as a MLAG 4. It means physically you have two switches, but host perspective, you are going to have switch like this. Logically, leaf 1, leaf 2. Logically, this host will consider the single box, just like a BPC, if you understand the BPC. Okay, so what I've done here is run. If you see that 1/4 interface, I have configured that the host 1, which is this one. I'm saying the channel group 4 mode active. On the channel group 4, I have configured the VLAN 12 as an access port and allowed configure the MLAG 4. MLAG 4. Same thing I want to do for towards the spine switches here. Towards the spine switches, I want to configure the port channel 12 MLAG configuration. The MLAG 12, for example, I want to configure. Okay, the moment you will configure this one, this is the physically 4 devices you will see here is the logically they will act as like this big box. They have single domain, they have single domain, they have single domain. So like this. Though they are physically 2, the host perspective, these devices are single device. Even if one device goes down, nothing will happen to the host. This is the high availability you are going to get using this MLAG concept, just like a BPC, Nexus BPC. Okay, or stacking. Is the advantage of the MLAG and BPC is both the switches can act as an active, unlike the stacking where your one device act as the control plane perspective, one is active and other is a standby. Similarly, but here you have both the control plane and data plane as an active. This is the advantage we are going to. So what I'm going to do is port number 2 and 3, I will configure. I will log into the spine switches. Okay. Then I will check that what is the configuration on the spine switch. If you see the run, on the spine switch, MLAG is already configured between the spine 1 and spine 2 using the same kind of VLAN. And I have one interface VLAN 12, which is SPI created on the spine devices. This spine devices using the SBI, and using the SBI, I have configured one virtual IP address. Okay, one virtual IP address. Just like a VRRPHS RP, you have that concept to generate the virtual IP. In Arista, you have the command called that IP virtual router address, and I've created the 172.16.112.1. This is the virtual IP address, which this host will use for the communication. Okay, as well as spine switches also have been configured for the MLAG configuration. If you see that, LLDP neighbor, if you see that I have these boxes, leaf 1 and 2 connected to the port number 2 and 3. Now, if you see that port number 2 and 3 configuration, port number 2 and 3, port channel 12 is connected, and port number 12 belongs to the MLAG 12 on this particular box. Okay, same way I'm going to, and I have it allowed the VLAN all between the switches, not just VLAN 12. So what I will do here, I will configure the port channel MLAG between the spine 1, spine 2, and the leaf 1, leaf 2. I will say the interface 2 and Ethernet 3, sorry, not 4, 3. Then I will say that the description for this one is spine. I have to individually spine MLAG. Okay. Then I will say the channel group 12 more active, no shutdown. Exit. Then I will say the interface port channel 12 switch port mode trunk. Then I will say that the description is spine MLAG. Okay. Then I will say that the MLAG configuration for here is the command is very straightforward. Just like a BPC 10, 12, whatever you configure, MLAG 12. If you see that how many numbers we can give, the MLAG ID you can use between 1 to 12 to 2000. I'm going to give 12. You can use any number. Same way, I will go to the spine leaf switch 2. So sorry, leaf switch 1. I will say that interface Ethernet 2, Ethernet 3. I will say switch port mode trunk description spine MLAG. You can give the description on the individual interface also. I will say that channel group 12 mode active, not shut down. Okay, then I will say interface port channel 12 switch port mode trunk. I'm going to allow all the VLAN. Okay, so and I will configure that MLAG 12 description is spine MLAG. If I go and check the SORM configuration, I should have this exact configuration over here. Now, if I say that here, so interface status, I should have the VLAN 12. Now, if you see that, what is allowed on that? So spanning tree, if you see that on the spanning tree, currently by default, it is taking that MSTP, multi-spanning tree. But if you see that this is the root and all the communication is working fine, if I say the so VLAN, on the VLAN side, the VLAN 12, 34, 1, and is allowed on the port channel number 12 and 10 and 4. Okay, how this is allowing there? I have VLAN 12 allowed on this side also, this side also, this side also. So if I go to this host device, which is again is my one of the switches we have. So if I log into this box, if I say the so interface status, you will see that there is port channel number 1 and 2 and other ports are also connected. If I check that, so run. These all are the 1 gig interface I have. On the port channel 1, if you see that, this IP address has been configured. Okay. However, if you see the port channel number 12, the port channel number 12 is going towards the port channel number 1 is going towards my switch 1. Okay. Now on the switch 1 side, if you see that I have this IP address which has been assigned on the switch here, which is again it's just a layer 3 port channel I've created that. Now if I go to the leaf 1 should be able to discover the MAC address, that one of VLAN 12 IP address. If I go to the spine switches should also receive that. But before receiving that, I want to check that. So MLAG interface. See that MLAG 4 is connected, MLAG 12 is connected over here. Now, if you want to check the more details, there are several commands we have, like so MLAG interface member. All the member interfaces of the MLAG will be showing over here. If you want to check the interface state of the MLAG. So MLAG interface states active or configuration, I think. Currently, I think is not configured or what active full. This is the currently it will give the output. Now, if you want to check the ISSU, if you want planning to upgrade MLAG, anything like that, so you can run this. So MLAG ISSU warning. It will give that warning before upgrading, saying that if you are performing the upgrade, the release of this node, it will give that the what be going to be impact. This is the virtual lab. This will go show that impact of the this upgrade if it, at all is going to happen in the environment. Okay, now if I go to the host and try to ping my SBI, which is created on the spine switch here. Now the spine switch, if I go to show IP interface brief, on the spine switch, I have a VLAN number 12, and the virtual IP for VLAN 12 is a 1.1. This is the IP address. Now, if I try to ping from here to here, it should be like this. Okay, so if I go to the host and try to ping 172.16.172.16.112.1. Plane, I have to type ping. Look here. Exactly. If I try to ping the .2, which is a physical interface, also going to reply that from spine 1 and spine 2. Okay, so if you see that I have assigned the IP address .2 here, .3 here, a virtual IP address for the VLAN. So this is a plain, MLAG configuration using the CLI. There are some advanced configuration for MLAG. For example, if you want to configure the failover scenario on the MLAG, right? How you can achieve this configuration? Because by default, if one MLAG fail, you might have a chance to have a create the loop in the environment. Okay, so in this case, you have other option called the peer gateway and the other thing, but here you can delay the configuration, delay the peer role switch or any other thing. Okay, so for example, if you want to configure the before that, let me give you the more detail of the MLAG. If you want to configure, so MLAG, there's one command called details, where you can get that all the sort of details. Look here, saying that this is the MLAG details, and saying that this is the primary switch, this is the secondary switch, and this is all the state of the failure. Currently, there is no false, there is no failover, and the peer port error disable is not configured. And if you see that the last heartbeat is this one, and if there is a heartbeat loss between the devices, you may have a issue in the network. However, you have a option, the one command configuration. So if your primary fails, okay, the command is if your primary fails, just like a BPC, if your primary fails, your secondary switch by default disable its interfaces in a error disable mode. When I say the error disable mode, it will include that layer 2 port channel, SBI, all these things. So if you want to avoid this kind of scenario, there is a one command we have. Okay, there is a one command we have. We can configure this the dual primary detection in the environment if you like to. You can configure that. So how you want to configure that here is, there is a command, you have to enable the heartbeat between the devices. Okay, once you enable the heartbeat between the devices, you can delay the configuration. For example, there is a command called the configuration, sorry, MLAG configuration. There is a lot of command you will see here is dual primary detection, the configuration dual primary parameters. It means if primary fails, okay, the secondary switch will not suspend its support for certain time. Okay, for a certain time. So it will by default is taking that around 4,000 millisecond or something like that. Okay, now if you want to configure this, you can configure that. There is a command called the primary recovery delay. The command configure on the primary detection recovery delay. Okay, for the MLOG interfaces, for the non-MLOG interfaces, which will, default value for both the switches will reset to 0, and it will take around 60 seconds to, by default, it's suggested to have a 60 second for the configuration. Okay. When you're trying to do that ISSU, upgrade kind of stuff. So in this case, the dual phase scenario is a commonly happen. Okay. So if you see that there is a command called the dual primary detection delay. Okay. Can be 5 seconds, and say the action either disable. So before putting the interfaces all into the either disable mode for the secondary, you just make sure that you configure this command. Okay, and the moment you will say that, so MLAG details, you will find this command in your status. Dual primary detection, saying that currently is not detected as of now. Okay, on the peer side also you can configure the same command, dual primary detection over here. Now, if I want to configure on the MLAG2, I can configure that MLAG configuration dual primary detection delay 5 seconds before action is either disabled. All the interface. Okay, this is the command which you can run to check that. If, for example, so interface status either disable. If any failure happen, your error disable will be showing over here. So this is the command where you can configure the error detection mode for the MLAG devices. Okay, there are more like heartbeat. If you want to change the heartbeat of the devices, between the here by default heartbeat is, I think, much is heartbeat is saying that here. Peer failover detection is unknown currently. This one heartbeat is currently is this much, which is huge. It's not recommended to have that. It should be around, I think millisecond is around 10 seconds, if I'm not wrong. So you can minimize like 2 seconds or 3 seconds if you want to minimize that. If you can, for example, MLAG configuration heartbeat interval is 25 milliseconds. Okay, you cannot configure in a second. Then I will say that. So MLAG details you can show over here. Look here. So accordingly, you can configure the reload delay also. If something happen in your environment, MLAG side, you can configure this a peer gateway command type of command, just like your virtual MAC address or MLAG kind of things configuration. Like just on the spine switches, if I go to that, show run, if you see that there is one command, if I have run that or not, I have not run that. Okay, so this command, the peer virtual router. So if you are running this command, okay, this command, you make sure that you have to configure the peer virtual MAC address also. You have to randomly assign that one MAC address to make sure that you do not have any kind of conflict between the spine 1 and spine 2. And this is only possible when you have the MLAG configured between the switches. Okay, so yeah, so this is the MLAG, the basic and back-to-back MLAG, and I will be configuring MLAG using the cloud vision of the Arista, which is the SDN solution. Stay tuned. We'll see you in next session. Thanks for watching. Please, if you like the video, please do subscribe.